We're going to be working on Chapter 14, Exercise 14-21. I did want to point out to everybody that it is possible to get the solution files for the even-numbered problems from the author's website, so feel free to go in here to access that to use as a guide to solve the even-numbered problems. Now, you do need to sign up using the access code from your book to be able to get to the solutions for the even ones. So that's one of the reasons why you need to get the book and need to have the access code. But we are going to skip over this problem here, which is 14.18, and we're going to move on to 14.21. All right. So this particular problem says, write a program that draws two filled circles with a radius 15 pixels centered at random locations with a line connecting the two circles. The distance between the two centers is displayed on the line as shown here. Okay, so we got a couple different things to deal with here. Okay, so drawing two circles with a radius of 15 that's filled, piece of cake, right? What's not a piece of cake necessarily is they're centered at random locations. So we don't know where they're going to appear. We're going to write a little math, random thing that's going to make them go to different spots, and I'll share with you the formula to do that so you don't sit there for 3 days trying to figure it out. Although my guess is if you Googled it, somebody on Stack Overflow probably has a answer for you. And then the next thing that we need to do is have a line that's going to work from those center points. So really, once those center points are set, then we can use those same coordinates to draw the beginning and ending point of the line. Once we have the beginning and ending point of the line, we are going to determine the distance. How do we determine distance between 2 points? Enter 4th grade math. If I knew what these points were, how do I know that distance? Yeah, I'll get my tape measure and I'll measure it. No. How do you determine that? All right, I'm going to make you guys take that math prereq again. It should be really simple. Triangle. This is the right triangle. A squared plus b squared equals c squared. So you need the starting and ending points. From there you need to be able to determine the x and y position, which you're going to have. So if the x on this is, let's say, 40, we know that. If the y on this is like 300, we know that. Therefore, we have this distance, and we have that distance, which means we have this as well. So it's just a matter of writing the formulas to do it. Okay? My anticipation is we'll probably chew up through all of the next class doing this, but we're going to get a start. All right. So let's begin by creating the program. All right. I paused the video for a second to grab some of the base libraries that we're going to use, and pasting them into this website called CodeShare that we use here in the classroom, where we just throw code in and we can each access it and edit it live. So if you're ever interested in trying it out, just go to this website, codeshare.io. This is the one that we've been using in class, so you're always welcome to jump in. But keep in mind it's like a scratch pad, so things change. All right, and I'm just using that to help start our application. All right, so we're going to create a new project. It's going to be a JavaFX project. We're going to call it exercise 1421. And then in that exercise, we are going to create a new class. We use the default package. And call exercise 1421. And since I've already got the beginning part of the application here, I'm just going to copy that. And then I know that the start needs a closing curly bracket. I know the application needs a closing curly bracket. So we have a little bit of a beginning here. Right. So I put in the pane because we know we need to throw the stuff into a spot where we can draw it. Agreed? And then we need to figure out what is the next step. What to you guys would be the next logical place to proceed? Create the circles. All right, so we're going to need 2 circles. Shall we call them circle 1 and circle 2? Okay, and here I'm taking a really quick pause. And the pause is going to be, what are we going to put inside these parameters? Really all we need for a circle?
The radius.
The x and the y.
No.
And the radius. Yes, we could just put in a radius.
Call just the circle at a point.
Okay. But how are we going to... So, for example, I know where your head's going right now, because mine goes the same place. But we need to do, let's say, I'm just throwing in numbers here. Let's say we do an x and a y position, and then the radius. Okay? But the x and the y position are going to be randomly generated. So we should put in some variables here. So, and my thinking is we'll have an x and a y for each one, right? We know the radius is going to be 15. That's a given. You guys see where I'm going here? But we need to declare x1 and y1. So we are actually going to create, what should it be? Should it be an int? Should it be a double? Yeah, double is my choice too. Is there a reason why you're thinking double? Just for size, and that is the correct answer, because we don't know, what the limitations are going to be, so it just gives us some room to work with. Now, if we're going to have an x1 and a y1, our other circle is going to have an x2 and y2. And I know I'm kind of doing this in a little bit incomplete fashion, but I'm just trying to kind of use like a scratch pad kind of approach where I'm throwing the stuff in there, and I know I need to go back and fill it in. So, but I need an x1 and a y1, an x2 and a y2. Now, these are going to need to be randomly generated. So now the question is, how? Well, yeah, that's going to be a given. So we're going to do math random shouldn't be so hard to type that. And then we need some sort of a parameter to multiply against. Now I happen to have a little cheat here, and what I'm trying to figure out is when you do a math random, you multiply. In fact, as I type this, I'm going to retype it. Let's actually do it from scratch. And what I'm trying to do is invoke this little screen here. And it says, returns a double value with a positive sign greater than or equal to 0.0 and less than 1. So it's within a range. And then you need to go through and do a multiplier to convert that decimal number that goes from 0 to 1 to whatever numeric format you're going to need. So we need to get it to be in an X and a Y range when we don't want decimal numbers, right? We want larger than that. So how would we take, let's say, a 0.5 and make it 5? Multiply by 10. That's a pretty reasonable approach. Are there any other considerations we need to make? Because if you think about this carefully, we need that circle to end up inside the pane that we make, right? So another thing that would be really helpful to do is to declare the size of the pane. Now we could hard code that, or we can set up variables once again for the pane so we have a parameter within which to work. Okay, so now I'm not abandoning the math random, but once again I'm taking kind of a scratch pad approach here, realizing that I need to come up with height and pane width. And then each of these needs to be declared to some value. And I'm just looking here at our sample drawing. Now I'm just going, if this is 211, it would seem to me that this is at least 200 across and tall. All right, so what about like 250 and 250? Other thing that we need to consider is, great, okay, so now we have some parameters from which we can work against. So whatever we do has to fall within, the x's have to fall within 0 to 250 and the y's have to fall between 0 and 250. But we don't want the circle, ideally, I mean I guess you could make it so that it will touch the edge of the screen, but we really don't want it to do that. And if we know the radius is going to be 15, in order to keep it from touching, we need to do what as a value? This is a little bit of a head scratcher, right? Because, okay, so if we want whatever the width is, let's say if this is 250 and the radius is 15, so 15 plus 15 is 30, so it really gives us 220 pixels to work with, and that's touching the edge of the screen. So we need to come up with a number. So basically what I'm going to do here is, for a multiplier, and this is, keep in mind here, this is something that's been tested. So if the pane width is 250, I subtract 12, that puts me where? 238, right? So 238 times whatever this comes up with. So just for example, if I was to use my calculator and I was to say, let's say the random number generator came up with 0.4. Okay, just a guess. And it might be some other decimal value. And we multiply that times pane width minus 12, which is 138, so times 238. So this is just an example. So now it's going to put us as an X position of 10472. If we were to, let's say it came up with 0, actually 0 wouldn't work, would it? Oh yeah, it would. Okay. 0. Okay, so I'm thinking that maybe my logic isn't quite right. Let's say it came up with the value of 0, okay, 0.1. We use a better scenario. And multiply that times 238. Let's try it one more time. Okay. So what I'm trying to show you is, like, I can just put in a bunch of different values here and it should come out with stuff that's always in the range and not touching. All right, so let's just take that as workable, if you guys are comfortable with that. And now, basically, I'm going to just copy this. So now we have size of the pane. We have a way to generate random x and y's. Is it possible that the x and y's might end up in the same position? It's possible. You think it's likely? It's highly unlikely, but it is possible. Maybe like winning the lottery. Okay, so now I can go back to making my circles. So I'm going to copy this one and create a second one. And this is going to be x2, y2. I am saving my work. And it just dawned upon me. I'm going to pause for a second. All right, so now that we have all our random stuff, we got our window size, we've got 2 circles with random center points. The next thing that we need to do is we need to figure out a line, right? And that line's, this is going to be pretty easy, actually. And the line needs starting xy, ending xy. Well, that's a piece of cake. It'll be whatever x1, y1 is, and x2, y2. Piece of cake. All right. One more little tidbit I'm going to throw in here is text, because that value, where is that? That value that we see right here, that's got to go in a text box, or in a text container. And then we need that value to spit out as well. Believe it or not, it's not that hard to get it. So actually it looks like we're going to finish this. I thought we weren't going to be able to get to that point, but I think we're going to be able to finish this before we switch gears. So we are going to say new text, and then right inside the text we're going to do our formula. So I'm going to do x1 plus x2. Now I'm not making these formulas up. These are part of the Pythagorean theorem. If you look at like how to figure out the distance between 2 points, this is how you do it. And we're going to divide that by 2. And then we're going to do the same things with the y. That's also divide by 2. And then we're going to throw in this little constructor here. And this is why we have this library, point 2D. Now if you manage to figure this out on your own, excellent. you wait till this video comes out to figure it out, that's fine too. It's not a problem. I think that's all we need there. Just gotta make sure we get our semicolon. And we're gonna test it in just a minute. So I'm going to pause our video there for a second. Okay, so we're hoping to get this output. We do need to put in all the stuff that's going to help us display everything. So part of what we're going to do is we're going to do this get children add all. So let's go ahead and put that in here. Of course, the names are going to change. So what things are we going to display? Yep. Circle 1, circle 2, and the line. Oh, and the text too. Yeah, we got to see the text. That's helpful. All right. All right. I should probably be polite and change this. And then we need to launch. So I'm just going to come back here, grab the main method. Save it. I am now crossing my fingers that it's going to work. Yay! Worked. And really, most of the work, you know, in terms of like the difficulty of it, is happening in this formula. And this is just the regular distance formula. And then this is declaring a spot to place that particular line, and it's taking that distance, which is relative to the x1, y1, right? So it takes that x1 and y1, it runs a built-in method that takes the coordinates and places everything. So this is actually a result of the x position, so we're kind of averaging between the two. So if the x's, if one x is, let's say, 50 and the other one's 100, this one's getting placed at 25. So it finds the in-between point of the x's and in-between points of the y's to put the beginning of the text. The other part, the distance formula, that's built in as a method. So that wraps that one, and we're on to new things.